Hello, this is John from Military System Explained. In modern artillery, if you shoot and stay in the exact same place, you die. It's that simple. And that specific problem is exactly why the Panzerhaubitze 2000 exists. It's easy to look at it and just see another tracked 155mm gun. But under the armor, it's a highly automated firing platform built for one specific job: to dump a massive amount of explosives on a target and get out before enemy radar even figures out where the shots came from. Today, we're going to tear down the engineering behind the PzH 2000 and see why, decades after it was designed, it's still considered the gold standard for self-propelled artillery. To understand why the Germans built this machine, we have to look back at the late Cold War. NATO had a massive problem: Soviet artillery doctrine. The Soviets planned to win by sheer volume of fire, and NATO simply couldn't match them gun for gun. They needed a qualitative edge. The older systems, like the American M109, were reliable, but they were too slow to set up, fire, and move. The new requirement was strict: build a platform that could roll up to a position, fire a rapid burst of standard NATO 155mm shells, and pack up before the enemy's counter-battery fire arrived. They didn't just need a bigger gun. They needed a machine that took the heavy lifting away from the human crew, to push the rate of fire to the absolute mechanical limit. To make that happen, the engineers were handed a brutal list of requirements. At the core of the project was the new 155mm L-52 gun barrel. This wasn't just about reaching further. It was about standardizing ammunition across NATO, while pushing the effective range past 30 kilometers. But the gun was only half the equation. The crew needed top-tier ballistic and NBC protection, because in a near-peer war, you are always being targeted. Above all, the platform had to be capable of firing 3 rounds in under 10 seconds, and then driving away before the first shell even hit the target. They called it shoot and scoot, and to achieve it, they had to completely rethink how a howitzer was built. Faced with these specs, the designers at Krauss-Maffei-Wegmann had a choice. They could try to build something light and easily transportable by air, or they could accept the weight and build a fortress on tracks. They chose the latter. They completely abandoned the idea of a lightweight compromise and went with a heavily armored chassis, borrowing proven components from the Leopard main battle tank family. This gave them the sheer mass and stability needed to handle the violent recoil of the L-52 gun during rapid bursts, without needing to dig physical spades into the dirt. The most critical design decision, however, was the fully automated loading system housed inside that massive turret. By storing all 60 projectiles in a star-shaped magazine right in the center of the hull, the autoloader could mechanically grab, lift, and ram the heavy 155mm shells into the breech, at angles and speeds a human crew simply could not safely match. Let's step inside the beast. The heart of the PzH 2000 is the Rheinmetall 155mm, or 6.1-inch, L-52 gun. But the gun is just the executioner. The brain is the MICMOS fire control system, and the nervous system is the autoloader. In a traditional howitzer, the crew does the heavy lifting, hauling 40 kilograms, or 88 pounds, shells, ramming them into the breech, loading the charge. It's exhausting, and human muscles tire quickly. In the PzH 2000, the computer calculates the ballistics in milliseconds, and the machine takes over. It mechanically selects the correct shell from the 60-round magazine, hoists it up, and pneumatically rams it into the breech. The human loaders only need to manually insert the propellant charges. This human-machine teaming maintains the relentless rate of fire, without burning out the crew. Let's put the raw numbers on the board. Combat weight, 55.5 metric tons, or 61.2 short tons. Top speed, 60 kilometers per hour, or 37 miles per hour. Cruising range, 420 kilometers, or 261 miles. Rate of fire, a 3-round burst in just 9 seconds. Maximum range, 30 kilometers, or 18.6 miles with standard shells, stretching up to 67 kilometers, or 41.6 miles, using rocket-assisted projectiles. But numbers on a brochure never tell the whole story. When you push this system into the dirt, physics fights back. During deployments in Afghanistan, Dutch and German crews discovered that fine desert dust and extreme heat choked the air filters, causing the fire control processors to overheat. The software forced crews to lower their rate of fire to prevent permanent damage. We saw this again in Ukraine. The PzH 2000 was designed for short shoot and scoot bursts, around 100 rounds a day. Ukrainian crews, locked in massive artillery duels, fired up to 300 rounds daily. This relentless pace burned out the air compressors and pneumatic seals, powering the autoloader. When that fails, the exhausted crew must manually ram 40 kilogram, or 88 pounds, shells into the breech. It's a high-performance sports car, devastating, but requiring constant, heavy maintenance. Moving from the drawing board to the battlefield, the PzH 2000 was a massive industrial effort. It was jointly developed by Krauss-Maffei, Wegmann, and Rheinmetall, with final assembly taking place in Kassel, Germany. The German Bundeswehr received its first production vehicle in 1998, initially planning to buy over 500 units. However, the end of the Cold War meant defense budgets shrank, and the final German order was cut down to just 185 systems. Despite the smaller numbers, it immediately became the backbone of their artillery forces. The production lines didn't stop there, as its capabilities caught the attention of Italy, the Netherlands, and Greece, all looking to modernize their aging M109 fleets. Tactically, the PzH 2000 fundamentally changed how an artillery battery operates. Because of the extreme automation, a single gun can perform a multiple-round simultaneous impact, or MRSI, strike. The computer calculates different elevations and propellant charges for up to 5 consecutive shots, firing them so they all strike the target at the exact same second. For counter-battery fire, this is a nightmare. By the time enemy radar detects the first incoming shell, the PzH 2000 has already fired its entire burst and is driving away. The system hasn't stayed static since 1998. Modernization focus has shifted toward digitizing the battlefield and extending the reach of the L-52 barrel. Upgrades like the artillery fire control system now allow for seamless integration with drone reconnaissance and satellite targeting. The biggest leap, however, is in ammunition. While standard shells reach 30 kilometers, or 18.6 miles, the introduction of the Smart 155 sensor-fused submunitions and the volcano-guided rounds has pushed the precision strike capability out to 80 kilometers. That's 50 miles. This evolution ensures that while the chassis is decades old, the brain and the punch remain at the cutting edge. Today, the PzH 2000 remains the gold standard for heavy, tracked artillery. It is currently operated by 8 nations, including Germany, Italy, the Netherlands, and most recently, Ukraine. Despite its maintenance-heavy nature, no other system in the world can match its combination of armor protection, ammunition capacity, and sustained burst fire. While newer, lighter systems are entering the market, the PzH 2000 is still the weapon you want when the mission requires holding the line in a high-intensity, near-peer conflict. It isn't just a relic of the Cold War. It is a proven, modern platform that continues to define the heavy artillery category. The PzH 2000 proved that a 55 metric ton, or 61 short ton, fortress could move and strike with the precision of a sniper. But is the era of heavy tracks and massive armor coming to an end? In the next episode, we look at a completely different philosophy. We're moving from German steel to Swedish innovation. Imagine a system that can deploy, fire 3 rounds, and vanish before the first shell even hits the ground. Next time, we look at the fastest draw in the north, the Archer artillery system. If you enjoy these deep dives into military engineering and want to see how the Archer compares to the PzH 2000, make sure to hit the subscribe button and turn on notifications. Leave a like if this breakdown helped you understand the complexity of modern fire support. It really helps the channel grow. Thanks for watching, and I'll see you in the next one.